Killer electrons. That is the real name, used by the engineers who fly satellites, printed in the scientific literature. They pass straight through the wall of a spacecraft and stop deep inside it. This weekend, the number that counts them crossed its warning line for the second day in a row. Every public space danger scale read 0 while it happened. No alert, no color code, nothing the rest of us would ever see. The hazard that has quietly damaged more satellites than any of them has no scale at all. Because this is the one danger up there that never strikes on the day you would blame it. The damage comes later, weeks later, on an afternoon that looks like nothing. So how many satellites have already died this way, with no one ever able to prove what killed them? And right now, that number is climbing again. Right now, the warnings are all about the part of the problem you can see. We have never launched so much so fast. Mega constellations of thousands of satellites, with thousands more approved. The low orbits where the internet satellites fly are filling, and so is the high ring where weather and television hang. Around 28,000 pieces of debris are tracked in orbit, and about 16,500 working satellites thread between them. A marble-sized fragment striking at a speed of 17,000 miles per hour possesses enough energy to rip open a satellite like a tin can. Every close pass now means an avoidance maneuver. There are people whose entire job is managing that traffic. This month, a new survey called the geostationary belt a minefield, because the junk that high stays there, essentially forever. The nightmare version has a name from the 1970s, Kessler syndrome, where one collision makes the debris that causes the next. Even the missions carrying people back to the moon have to thread out through all of it, and they cross it fast, on purpose. That is the story on the front pages. Too much metal, moving too fast, in a space that is running out of room. It is real, and it is getting worse every year. It is also not the only danger satellite operators worry about. And yet, empty that sky tomorrow. Yet just one satellite out there, and the danger this is really about would still be there. It was never about traffic. The belt was here before the first satellite went up. Collisions leave wreckage you can point to. The hazard engineers actually chase leaves a working satellite that simply stops obeying. No debris, no impact, no mark of any kind. There is a map for the junk. For this, there is a single number and a warning line. And this weekend, the number went over it. Twice. So the question that runs under everything else up there is this: how many machines are already dead from something that leaves no wreckage? Earth is wrapped in 2 rings of trapped particles called the Van Allen belts, discovered by Explorer 1 in 1958. The outer ring is the one that matters, because it is full of electrons moving at a large fraction of the speed of light, and the orbit where most of our communications satellites live lies within or near the outer radiation belt. That is not a mistake anyone can fix. The orbit that lets a satellite hang over one spot on Earth happens to run straight through the belt. That orbit is about 22,000 miles up, far enough that you could line up the whole planet almost 3 times between your feet and the satellite. From up there, a single one of them sees almost half of Earth at once. These are the electrons from the beginning, and this is what the name is actually describing. What makes them dangerous is not the speed for its own sake. It is where the speed lets them stop. A slow particle from the solar wind stops on the outer skin of a satellite, where charge has been drained away safely since the 1970s. A killer electron passes straight through the outer wall and comes to rest deep inside, buried in insulation that was chosen precisely because it does not conduct. The charge arrives, it stops, and it has nowhere to go. You already know what this feels like. Walk across a carpet in dry socks, reach for a door handle, and something bites your fingertip. That spark is thousands of volts, and it is harmless because it has somewhere to go, through the handle, into the building. It's gone. Inside a satellite, there is no door handle. Picture it building over days, not seconds. Somewhere in that orbit, inside a working satellite, more electrons arrive and stop in the same layer, and an electric field grows in a material that was never meant to hold one. Hold your hand still for a second. Nothing about that moment feels dangerous. The space around the satellite is calm. Every screen on Earth reads 0. And that is exactly when it fires. A spark the size of a fingertip, a bolt of lightning going off inside the machine's own body. A switch throws that no one commanded. The satellite carries out an order that was never sent. The electrons that did it arrived weeks earlier, on a weekend the forecast called quiet. So the count keeps climbing, and no one can point to the moment any single one joined it. For a solar flare, cause and effect are locked together. The flare peaks, the radio blackout hits, the timestamps match. For this, the cause is a slow buildup over 2 to 3 weeks. There is no moment to point at, no photograph, no aurora over a mountain for a front page. So when engineers pull the record after a satellite misbehaves, and the space around it was calm that day, space weather never makes the list of suspects. The failure gets written down as a component fault of unknown origin, and filed in a private database no outsider will ever read. Set that against the junk. Every dead fragment up there has a catalog number and a tracked path. The thing that actually ends satellites gets filed under unknown. Failures are commercially sensitive. They touch insurance, contracts, the value of a fleet. MIT/Space Weather Journal Reference Card. In 2015, a team at MIT tested that idea directly against 26 amplifier failures on communications satellites over 16 years. The failures did not track the storms of the day they happened. They tracked the radiation dose the satellite had absorbed over the previous 2 to 3 weeks. And when they modeled the cable insulation, the charge built up over those weeks was enough to break it down from the inside. And here is what makes it worse now than 20 years ago. The chips that run a modern satellite are smaller, which means the voltage it takes to upset one is lower. A spark you can feel is thousands of volts. The parts inside a satellite can be upset by a small fraction of that, far below anything a human body would ever notice. Let's be clear about what rides on these machines. The storm map on the morning news, drawn by a weather satellite in that same orbit. The emergency broadcast that reaches a valley where the cell towers do not. Military communications crossing oceans. Aircraft staying connected far beyond the reach of ground stations. And the timestamp on a bank transfer. Because the clocks that put transactions in order are set by satellite, and being wrong by milliseconds is enough to break the sequence. None of that feels like space. It feels like an ordinary Tuesday. And all of it depends on hardware flying through the same particle environment, on orbits no operator can simply leave. So the question sharpens. If the damage hides for weeks and files itself under unknown, how many have we already missed? In January of 1994, 2 Canadian satellites failed 9 hours apart. Television went dark, data links dropped, and remote northern communities lost their phones. That is January in the far north of Canada, and the line that connects a village to everyone else simply stops working. Investigators ruled out everything but one thing. A discharge inside the spacecraft had corrupted the control loop of a spinning wheel and told it to wind down to nothing. It happened during a stretch of heavy electron flux. Then, in 2010, a communications satellite stopped answering the ground while its transmitter kept broadcasting. It drifted uncontrolled across the belt for months. Engineers nicknamed it the zombie satellite. Its operator blamed an internal discharge. Researchers tied it to the space environment. And once, we ran the experiment on purpose. In 1962, a nuclear warhead was set off 250 miles above the Pacific, and it left behind an artificial belt of trapped electrons that lasted for years. At least 7 satellites died in the months that followed, including the one that had just relayed the first live television across the Atlantic, its command channel going silent that November. That is the one time the cause is not in doubt. This one is proof that trapped electrons, not the flash itself, are what kill satellites in the weeks after. You would think the danger falls as the sun calms down. The sun is now sliding into the quiet, declining phase of its cycle. Fewer flares, fewer headlines. But the driver changes as it quiets. As it declines, the belt gets loaded instead by coronal holes, open regions on the sun that fire a fast stream of wind and that rotate back in line with Earth about every 27 days. And the one public scale that does exist is close to useless for it. A storm may load the belt, or barely change it at all. It measures the storm, not which way the electrons will go. When that alert reaches the people who fly these satellites, no one panics. They don't shut it down. They don't move it. They can't. The orbit they need is the belt itself. So the only move left is to stop moving, hold the risky maneuvers, and wait. Weeks later, if a fault appears, it is logged as unknown. The belt is loaded right now, and in about 27 days, if the hole that loaded it holds, it swings back and loads it again. But that was never really the question. We built a map for the metal. Every dead fragment up there has a number, a path, a warning when it comes close, because we can see it. We are writing traffic laws for a crowded sky. The thing that has quietly taken more satellites has none of that. No map, no maneuver, no scale. One number sent to a few hundred people. Same orbit, 2 dangers. One we all watch, and it's not the one doing the most harm. Every public scale still reads 0. So the real question is not whether a storm is coming. It is how many machines the invisible one has already taken, while every screen we own was pointed at the junk. The storm map on your morning news will look exactly the same either way. And the machines it has already taken, we will never be able to count them. There is more to explore. See you beyond the stars.